Hello, I am Keigo Imai from Gifu University in Japan, and this is a poster talk of our eCoop 2020 research paper, Multipartite Programming with Global Protocol Combinators, which is a joint work with Rumiana Neikova, Nobuko Yoshida, and Shoji Yuen. In this presentation, I will introduce our artifact, Okamura MPST. Okamura MPST is a library for writing deadlock-free concurrent distributed programs. Writing a concurrent program is notoriously difficult. In this simple link-based protocol, we already encountered some issues. Firstly, the order of actions should be written correctly. In this case, the process A must do an output first, then an input next. Secondly, the direction of communication must be correct. Apparently, writing a prescribed communication protocol will resolve them. So the best practice is design a communication protocol and check it, focus on its local behaviors, and enforce the protocol in the program code level. Our Okamura MPC library follows this best practice based on multi-party session types, and here is the usage. The programmer will write a communication protocol in Okamura. Here is a link protocol from the previous page. And then Okamura type checker will check deadlock freedom of the protocol, which is based on the well-foundedness of the multi-party session type theory. And this type checking is just based on the usual subtyping polymorphism, so the checking is very lightweight. Then, the protocol is enforced in the program in a usual type-directed way. The key features are, first, it is correct by construction based on both multi-party session types and Okamura type system. And this library exploits Okamura's low polymorphism for fine-grained code reuse and protocol reuse. Moreover, it is practice-driven. The extension include LWT, the lightweight thread library in Okamura, TCP, ATTP, and more. Curious on typing technology for deadlock freedom? Join in our demo from now and research paper talk which begins in 9 hours and visit our repository. Now let's start coding. Here is a protocol called two-buyer protocol, which often appears in the literature. It consists of a seller S and two people, Bob B and Carol C, buying an item together. The basic construct is arrow combinator, here saying that S sent to B with a label item. The fixed point combinator makes a loop where the variable t is bound to itself. The variable t occurs here, making a recursion. The choice combinator declares a branch saying that Bob makes a decision with two alternatives. The upper half starts by sending the result to C, and the lower half starts by sending the offer to C. And if I make a mistake, for example, if I mistype the participant name B as S, then Okamura compiler will report a type error. In this case, the compiler complains an error in the behavior of S receiving from C, which is introduced by the typo. So let's fix it. Now we have a deadlock-free protocol in our hands. To write the actual threads, we must extract channels from this G. The chain primitive here will extract such channels. Since we have 3 channels, Sarah, Bob, and Carol, we extract 3 channels here. See that the session types are inferred from the global protocol written in the above. And here are the threads. Sending is done by send function, and its destination Bob, here role B, and the label name item is specified by a hash operator, which is a method invocation in Okamura. The reception is done via receive function, and the origin of the message role B is specified via method of invocation as well. The received value is matched against the label final, and the here symbols with the backtick is the polymorphic variant in Okamura. And of course, if make a mistake, then the type error is reported by the Okamura compiler. Here is Bob. The point here is that the program structure actually matches the protocol structure, and it is verified by the Okamura compiler. Here's Carol. She also makes a loop, and she makes a pattern matching on the received value between the level offer and the result, which is so-called external choice. If we forgot the alternative, which is actually dangerous, then the Okamura typeset quickly notices the error. Let's run the program. They negotiate the price and terminate. This concludes our demo session. Thank you for watching us.